Pressure relief valve has become a common term covering a variety of devices used to prevent excessive pressure buildup. Many different designs are available for a wide range of applications and performance standards. A pressure relief valve is designed to open in order to relieve excess pressure and then to close once pressure conditions have returned to normal. They can be classified either by rapid opening or by a speed proportionate to that of the opening pressure. The general term pressure relief valve also includes safety valves, relief valves, and safety relief valves. A safety valve is a pressure relief valve which is activated by inlet pressure. Safety valves are distinguished by a rapid opening and are typically used with compressible gases such as steam or air services. Liquid systems are best served by relief valves. Relief valves are designed to have a gradual lift proportional to the increase over opening pressure. The simplest way to explain safety relief valve is that it will perform as a safety valve when used in a compressible gas system and as a relief valve when working with liquid. The basic elements of the design consist of a right angle pattern valve body with the valve inlet connection or nozzle mounted on the pressure containing system. The outlet connection may be screwed or flanged for connection to a piped discharge system. However, in some applications, such as compressed air systems, the safety valve will not have an outlet connection, and the fluid is vented directly to the atmosphere. The valve inlet can be designed with either a full nozzle or a semi-nozzle. The full nozzle is typically used in safety valves for high pressure applications, especially when the process is highly corrosive. A semi-nozzle includes a seating ring which fits into the body. The advantage of this arrangement is that the seat can easily be replaced without replacing the whole inlet. The disc is held in place against the seat in the closed position by a spring. The spring is housed in what is called the bonnet. Discs used in safety valves have a huddling chamber within a shroud, which helps in the rapid opening of the valve. The disc is forced closed by a spring when the pressure returns to normal. A spring adjuster is used to change the pressure at which the valve will open. Once the set pressure is exceeded, the disc will rise off of the seat. Once the disc begins to rise, however, the tension on the spring will increase, which means that the pressure would have to continue to rise in order for the valve to become fully open and allow any significant flow. The additional pressure needed for the valve to discharge at capacity is called overpressure. Overpressure will vary depending on the type and the application of the valve. The special design of the disc arrangement helps to achieve the rapid opening by placing a shroud or a hood around it. The area within this hood is known as the huddling chamber. The hood creates a larger area to be exposed to the pressure. Since the lifting force is proportional to the pressure multiplied by the area exposed to the fluid, the opening force will increase. This overpressure helps to compensate for the increase in spring tension. With the disc still exposed to a larger amount of fluid, the valve will not close until the pressure drops below the original set pressure. The difference in the set pressure and the reseating pressure is called the blowdown. The blowdown is a set percentage of set opening pressure, typically less than 10% for air and gases, but sometimes up to 20% for fluids. This helps ensure the system's pressure is low enough to prevent immediate reopening. Blowdown rings may be installed in order to change the overpressure and the blowdown. The upper and lower rings are generally set by the manufacturer. However, they may be adjusted for more precise applications if needed. When the lower ring is at its highest position in the huddling chamber, overpressure is minimized, creating a rapid opening. When the lower ring is at its lowest position, a greater overpressure is required, but the blowdown is minimized. Thank you for viewing this procedure. If you need to test or have any comments about any aspect of this procedure, please click the appropriate link below.